Hello, am I audible to everyone?
Yeah, you're audible. Please go ahead and start, sir.
A very good morning and warm welcome to all the respected dignitaries, participants, my dear colleagues and professional friends to this 5-day faculty development program on emerging trends in civil engineering organized by Department of Civil Engineering, Gates Institute of Technology. Myself, P. Zahir Alam Khan, Assistant Professor in Gates Institute of Technology. It is my great pleasure to host this event and welcome you all on board of this FDP. I would like to thank our correspondent ma'am, Srimati V.K. Padmavatama Garu, Managing Director, Sriji Raghunath Reddy Garu, Director, Srimati V.K. Vani ma'am, and Principal Dr. Bhaskar Patel sir for their continuous motivation, support, and encouragement, and for being present here today in this session. Civil engineering is an oldest and professional engineering discipline that deals with the design, construction, and maintenance of the physical and naturally built environment, including public works such as roads, bridges, dams, airports, sewerage systems, pipelines, buildings, and railways. So now I would like to request the convener of FDP and our HOD sir, Mr. J. Ritesh, to give his address and welcoming message to the gathering.
Thank you, Jahir sir. Respected correspondent madam, MD sir, director madam, principal sir, distinguished speakers, colleagues, participants from various premier institutions, ladies and gentlemen, good morning all. On behalf of Department of Civil Engineering, Gates Institute of Technology, I am delighted to welcome this morning to a 5-day online faculty development program on emerging trends in civil engineering. I thank for being on the virtual platform. So far, we received 804 registrations from different parts of the country and across the globe too. Notable among them are from Abu Dhabi, Malaysia, Pakistan, etc. As the Faculty of Civil Engineering, we need to keep updated from the accomplishment and new technologies in our specialization and interest. I wish this FDP will definitely provide some prominent insights and significance about the recent advancements in civil engineering. I thank this opportunity to welcome all the speakers for accepting our invitation and to be the resource person for forthcoming sessions of this FDP. On behalf of the department, on my own personal behalf, I welcome you all. I wholeheartedly welcome today's resource person, Dr. H. Sudarshan Rao Garu, Professor, Department of Civil Engineering, Jawaharlal Nehru Technological University, Anantapur, for giving us his valuable time in spite of his busy schedule. Gates Institute of Technology, established in 2001, it is permanently affiliated to JNT Anantapuram and got accreditation to all its engineering, humanities, and basic sciences and management studies by NAC. The institution also got 2F and 12B from UGC and ISO certification. The focus is to inculcate learning habits with a positive attitude and ethically sounded values with the faculties and students. Progressive thinking of our late Sudhir Reddy sir Garu has made Gates stand tall as one of the very first and few educational institutions to completely run on the solar power. The institution is headed by Dynamic Managing Director G. Raghunath Reddy Garu, Correspondent Madam V.K. Padmavatama Garu, and our Director Madam V.K. Srivani Garu, who are being the best to make the institution scales new height. The Department of Civil Engineering was started in the year 2012 with an intake of 120. The department has qualified, dedicated, and experienced faculty and supporting staff. It has e-classrooms, seminar hall, equipped labs, and department libraries. We strive continuously to encourage our students, not only in the academics, but also we conduct to organize the internships like AutoCAD, Revit, soft skills, and personality development programs. We encourage our students for industrial visits, survey camps, traffic audits, and Southern Railway programs. The institution also for students to further enhance, update, and fine-tune much needed in the specific skills like the workshops in a different manner. In order to facilitate this, the institution is signed with an MOU, Village Energy Australia, Andhra Pradesh State Skill Development Corporation, and Florida Atlantic University. I trust you will have a productive session as we have an eminent speakers for all the 5 days from the reputed institutions and companies of the country. I would like to appreciate the participants who are willing to shoot their questions at the end of the session. Please stay tuned, stay safe, and stay protected. So get ready to quench your thirst for the technical knowledge. Technology amplifies us, technology connects us, technology unifies us. Thank you, one and all.
Thank you for your wonderful message, sir. Now it's my pleasure, and I would like to invite our beloved principal, sir, Dr. Bhaskar Patel Garu, to address the gathering. Sir, over to you.
Thank you. Very good morning to all of you. First and foremost, on behalf of the institution, on my personal behalf, we wholeheartedly welcome our chief guest and our mentor and our governing body member, Dr. Sudarshan Rao, sir. Sir, indeed, we are privileged to have you, sir, here today. Respected correspondent, madam, respected MD, sir, respected director, madam, and all the participants across the nation. We must admit this is fifth in the series of the FDPs that we have undertaken during this pandemic COVID times, say, during the last 122 days. And in all the FDPs, we have ensured that there is a clear blend of experts from industry and academic stalwarts, wherein the inputs given by the industry and the academic stalwarts really empower the faculty, not just of my institution and across the nation. So this we have been doing, and I take this opportunity to thank Sudarshan Rao sir for hand-holding our civil department, because our civil department is one of the youngest department in the institution, and you have come forward to support and handhold this department, sir. This has given enormous energy and strength for the department for us to go ahead with this FDP. And as mentioned earlier, there are more than 800 participants across the nation and overseas also to have proper technological support. What we are intending to do is the entire program will be live on YouTube, and the faculty members who are participating, who have registered, will be putting up their questions on the chat box. So at the end of the session, the organizers will be coming up, picking up those questions, and during the question and answer session, you can answer the questions, sir. And I'm sure, without taking much time, this 5-day FDP for the civil faculty will definitely enrich all the faculty. And we would only expect and request all the faculty members, the insights what you gain, the competencies what you build, and the skills what you acquire during these 5 days with the interaction with these industry experts and senior academicians, kindly see that they are disseminated to the student community in your institutions. So that is the bottom line, and that is the basic objective and purpose of conducting such an FDP. So once again, I welcome our chief guest, sir, and also I also welcome all the participants from all over India. Thank you very much.
Thank you for your wonderful message, sir. Now I'm privileged to invite our MD, sir, Mr. Raghunath Reddy, sir, to address the gathering. Over to you, sir.
A very good morning to all of you. Thank you, everyone. Thank you for joining today's Civil FDP on emerging trends in civil engineering. I'm speaking from the other side of the world. It's actually 20 minutes past the midnight. When my team members asked me to address the gathering, I feel it's really an honor for me to be part of this such a wonderful program. Of course, it's a beautiful day. I'm honored to welcome this group of outstanding teachers. You are all the best of the best. And even though we can never really thank teachers enough, today is a chance for me to offer them a small token of appreciation for the difference we all make in the life of our children and the future of our nation. Thank you all, dear professors, lecturers, teachers, all of you that you have been doing the great service to this nation. I want to start by acknowledging somebody who I think will end up being one of the greatest eminent personalities in the field of education. He's more passionate about making sure that our younger generation get a great start in their life. He's also passionate in guiding, mentoring students, lecturers, professors, and building better institutions. He is none other than Dr. Sudarshan Rao Sir. We are very fortunate to be associated with him. To be precise, we are fortunate that Gates is one of the institutions that was nourished under his guidance. He laid his first brick for the Gates Institution, not only for the civil engineering department, for the entire institution. And he has been continuously helping and guiding us to be one of the best institutions in this region. Sir, I would like to really say thank you very much for your continuous support you have been offering to us. There is nothing like this, the support that you have actually just offered so far and taking us to the new heights. Coming to the importance of the FDPs, the Gates has been conducting a very high quality faculty development program with eminent personalities that our principal sir has mentioned, Bhaskar Patel sir. So far, we have close to 40,000 participants for the FTPs that we have conducted for the various branches. We have participants from different states. So far, I think close to 13 states that we have it. And we have them from both from the national and international participants, as Mr. Ritesh was mentioning. We haven't compromised on the quality of the FTPs. We strongly believe that the game changers in the leading this nation in the next generation of technology. Without taking much time, I would like to thank the organizers for providing me this opportunity to interact with all of you. Thank you all. Once again, thank you all for your role in transforming the life of the students. And also, I would like to thank Dr. Sudarshan Rao sir for accepting to inaugurate and take part in today's faculty development program. I assure you, the programs that we are conducting here will be of very high quality, and then you will actually just learn something out from this, and you will be able to transfer that one to the students, and that eventually transforming the students across. Said that, I really wanted to say thank you very much for providing this opportunity, and thank you all.
Thank you so much, sir, for your valuable inputs. And now I would like to invite our correspondent madam, Srimati Vicky Padmavatama Garu, to deliver her speech.
Good morning to everyone. సుదర్శన్ రావు గారికి ప్రత్యేకమైన ఆహ్వానం. వాళ్ళని విధంగా చూసినందుకు చాలా సంతోషంగా ఉంది. It gives me immense pleasure to see the Faculty of Civil Engineering being connected with all of you through this virtual platform in this pandemic situation. I congratulate Civil Department of Gates Institute of Technology for organizing the 5-day faculty development program on emerging trends in civil engineering. I welcome and also thanks Professor Sudarshan Rao sir, Chief Guest of and resource person for today's inaugural session. సార్ మిమ్మల్ని ఈ విధంగా అంటే ఈ టైంలో కూడా మిమ్మల్ని చూడగలిగినందుకు మాట్లాడగలిగినందుకు సంతోషంగా ఉంది. ఇందాకే రఘు గారు చెప్పినట్టుగా మీ సపోర్ట్ మాకు చాలా ఎంతో ఉంది. అది ఎప్పుడు కూడా గుర్తుంచుకుంటాం. సుధీర్ రెడ్డి గారు ఇచ్చిన బెస్ట్ ఫ్రెండ్స్లో మీతో ఎప్పుడు కలిసి ఉంటామని తెలియజేస్తున్నాను సార్. థ్యాంక్ యూ సార్. I also thank the rest of the eminent speakers for accepting our invitation to share the knowledge and their valuable insights. This kind of platform provide educators, faculty, and research scholars to improve the quality of education and imparting the same to the next generation, which is essential. I hope all the participants will make the best use of it, FDP, and equip themselves with the experience to provide good research and quality education. And I also thank our principal sir, who is always very inspiring, motivating, and lead the FDP programs and all other such kind of programs very efficiently. I also thanks to MD Raghu and Director Vani also, who are giving the new directions and leading the institution in a better way. Thank you all of you, and wishing all the participants and a very good luck for it. Okay, thank you, sirs, and thank you all of you.
Thank you so much.
Thank you, madam.
For your valuable message. I feel very much privileged.
Ritesh sir. Hello?
Yeah, Bhaskar sir, I can hear you.
Yeah, I'm just checking with Ritesh sir.
Dear all, just bear with us for a few minutes while we are trying to actually just work on bringing the other person online.
Sorry for the interruption. So now I would like to brief a little on our chief guest and resource person, Dr. H. Sudarshan Rao sir, who is a professor in the Department of Civil Engineering, JNTU, Anantapur. So before handing over this session to Sudarshan Rao sir, I would like to brief a little about him. He has a teaching experience of total 36 years, in which 30 years he has held different positions in different institutions. He has worked as HOD JNTU Hyderabad, Director BICAD JNTU Hyderabad, Chief Engineer and Vice Principal JNTU Hyderabad, Director of Evaluation, Director ICS, Rector JNTU Anantapur, Vice Chancellor and Director JNTU Anantapur, Director Academic Audits and Director for IIIT RK Valley in Kadapa district. Sudarshan Rao sir has published nearly 176 research papers in various national and international journals, and also while doing his PhD, his thesis was awarded the best from the IIT Mumbai. At PhD level, Sudarshan Rao sir has produced 26 doctoral students and supervising 12 research scholars. And in MTech level, sir has guided 142 students with their final projects, and in the BTech level, sir has guided about 123 students with their projects. Sudarshan Rao sir has also been a visiting faculty and delivered expert lectures on various topics at IISc Bangalore, SVU College of Engineering Tirupati, Osmania University College Hyderabad, JNTU Kakinada, JNTU Hyderabad, and many other engineering colleges in the state and as well as in all over India. Sir has also authored and published many books which are mainly concentrated on the structural engineering subjects. So now I would like to welcome our chief guest and resource person, Dr. H. Sudarshan Rao Garu, to take over this session and enlighten us with his insights and experience. Thank you, sir. Over to you.
Good morning, everyone. Am I audible to you?
Yes, sir. You're audible to us, sir.
Okay. So, at the outset, let me thank the person who has introduced me for his kind words. To begin, even before going to the technical presentation, as an inaugural address, I have to thank the organizers, the management, and the principal and the head of the department of Gates Institute of Technology for organizing this 5-day FDP program on emerging trends in civil engineering. In this very tough pandemic situation, taking the threats as challenges and as the opportunities, a virtual platform has been designed. You all agree with me that before this pandemic situation, we were not very much inclined to go to virtual platform teaching. But this pandemic situation really brought in the importance of a virtual platform. And now we are able to connect to professors throughout the globe and able to conduct the meetings and faculty development programs on this virtual platform without really making them or troubling them to come to India or come to our own institute and deliver their lectures or the speeches. So this virtual platform has really given an opportunity to all the students to interact with experts throughout the globe without any difficulty. So I would really like to congratulate the management and the Department of Civil Engineering of Gates Institute of Technology. I was really happy to hear from the Managing Director, Raghunath Reddy, saying that more than 80,000 participants have already participated in various FDPs conducted by this college. I'm really proud to be one among this venture. First of all, I have to pay my rich tributes to my very good friend and also my good well-wisher, Sri late V.K. Sudhir Reddy Garu, who was such a wonderful personality and a great human being, who thought of introducing engineering education to the rural students of Anantapur district and neighboring Kurnool district, ventured to start Gates Institute of Technology at a rural location in Gutti. He would have as well chosen to start the college in Anantapur or Kurnool, but he wanted to provide the education to rural students, opportunities to rural students. So with that noble aim, this institute was started. And I'm really very happy to share with you that in those days when we apply for approval of AICTE, permission to establish a new technical institute, these online permissions were not there. It's all offline procedure in those days. So it is me, with my own handwriting, I have filled up the application for according permission to this college, Gates Institute of Technology. With my own handwriting, I have filled the application and we have submitted the application to AICTE New Delhi. So right from the beginning, the college has been working on very good discipline and moral values under the leadership of the late V.K. Sudhir Reddy. And now the correspondent madam and also the managing director, Raghunath Reddy and Vani. These people are now taking the college in new technological direction. Particularly, I have to appreciate the efforts taken by the managing director, Gajjala Raghunath Reddy, providing more and more programs to the students and also for the faculty to develop their own skills and enabling them to be job ready by the time they come out of the institute. So many skill development programs are being organized and conducted in Gates Institute of Technology. I get the information regularly and I'm really very happy that the institute is progressing very well. And no doubt it is one of the best institutes in the state of Andhra Pradesh and very reputed in the family of JNT University, Anantapur. So now, I think I can proceed to my technical session. Organizers can just clarify me.
Yes, sir. You can, sir. You can, sir.
So I was hearing from the principal and the head of the department that there are participants right from India to abroad, various countries, Abu Dhabi, Pakistan, and so many other countries. So my suggestion is, you please change the name of the FDP as a 5-day international FDP because it has a true international flavor. So I would suggest the principal to think about this and rechange the title of this FDP as an international FDP. That will give more mileage.
Yeah, surely we'll take your advice into account, sir.
Okay. Thank you very much for inviting me to be the chief guest. and to inaugurate this particular session, and also delivering the inaugural address, as well as now to present my technical address. So is my screen visible to all of you?
Yes, sir.
Yes.
You're able to see, sir. Sir, now we'll exit Zoom and join, watch you through YouTube Live, sir.
Okay.
Thank you, sir.
Shall I give some pause?
No, sir. No need, sir. No need, sir.
No
need.
need.
We can start.
Okay. So good morning, all the participants for this 5-day FDP program. The inaugural session is just completed, and now we are proceeding to the technical presentation. The topic I have chosen today to present before you is modeling high-performance concrete with hybrid neural networks. I know there are many young civil engineering researchers as participants to this FDP program. So that is why I have taken this topic, which is in fact a conglomeration of two very new topics of research area. Very new topics of research area. One is the high performance concrete. The other one is the artificial neural intelligence or neural networks. So both the topics are very new and have a great potential for the research. So my idea in choosing this topic is to provide the basic inputs to the young researchers who would like to work in the field of high performance concrete or neural networks or a combination of these two. So first let us begin discussing about high performance concrete. After that, I will introduce what is neural network. Then I will give an example how to develop a neural network with a combination of genetic algorithms for modeling high performance concrete. So that will be the flow of presentation. So what is this high performance concrete? So let us discuss. What is this word performance? Let us try to understand. Whenever you construct a structure or your own house or somebody's dwelling, you always think that the structure has to last for 100 years of life. That is the aim with which you start constructing a structure, maybe a bridge or a dam or your own house, whatnot, a cooling tower, whatever it is. But what is happening in practice, if you observe, structures which are built just 30 years back, they have come to a distressed state and they need rehabilitation and retrofitting now. Within 30 years, the structures have developed distress and they need rehabilitation. Why is this happening? You can see this phenomena in many places, particularly if you are residing in a coastal region or if you are residing in an area where there is very high rainfall. You are able to see the structures coming to distress and rehabilitation necessity within a span of 30 years. While we want the structure to live long for a period of almost 100 years, but their lifespan has got reduced to only 30 to 40 years. If you try to understand why this is happening, I would say in the last 3 decades or 4 decades in concrete construction, a lot of focus was given on strength aspects, and that too particularly the compressive strength of the concrete. we were focusing more on the 28-day compressive strength as a basic parameter for the quality control. All our mixed designs of the concrete were focused around this 28-day compressive strength and probably a target strength with a target strength. That is also target compressive strength. We never bothered about other strengths, that is tensile strength or the flexural strength or the performance of the concrete. Or other words, we have forgot or neglected durability criteria. What is durability after all? Durability is that concept which shall enable the structure to live long for its design life period. Say if I design the structure to live for 100 years, it should live for 100 years. That is durability. That is a durability concept. Till we got IS 456-2000 revision, there was very little focus on durability. So we were mostly focusing on the compressive strength alone, and we were not bothered about the durability aspects and the performance criteria of the concrete, particularly in conditions where there are severe environmental attacks on the structure. In addition, the mixed design of the concrete was not taking into consideration the purpose for which the structure is being constructed. If the structure is designed to resist tensile strengths or tensile loads or tensile stresses or temperature stresses, like if you take the cooling towers or reactors, the design criteria should be totally different from simple compressive strength criteria. So that is where the performance came into picture. Why is this structure needed? What performance the structure has to give and what loads it has to resist. Accordingly, you have to design your concrete to satisfy those requirements instead of blindly going with a 28-day compressive strength design. So that is the idea with which high performance concrete has started, and that is the idea with which we started doing research on high performance concrete. So what is this high performance concrete? Is it a new concrete? Is it different from ordinary concrete? No, it's not a new concrete. High performance concrete is not a new concrete. It is not a different concrete from what you know. It is not a different from the concrete what you know. It is the same. But high performance concrete is made with predefined targets and is customized to suit the requirements for which the structure is designed and the type of the loading the structure has to resist. So that is the difference between the normal concrete and the high performance concrete. So let's compare what is normal concrete vis-a-vis the high performance concrete. So the normal concrete, if you see, the design is strength-based design. Whereas in high performance concrete, the design is performance-based. And in normal concrete, we are using just 4 ingredients. What are the 4 ingredients we use in normal concrete? You all know. We know cement, the coarse aggregate, the fine aggregate, and the water. These are the 4 normal ingredients that are used in ordinary normal concrete. But if you come to high performance concrete, in addition to these 4 ingredients, we are going to use quite a number of other ingredients, which we will see slightly later. So then, why is this high performance concrete required? You know, you heard about high strength concretes which are producing a compressive strength of 50 megapascals or 60 megapascals. The high strength concretes have been developed by incorporating huge quantities of the cement. But actually, if you incorporate more and more quantities of the cement in concrete, it is actually affecting the durability and long-term performance of the concrete. And because we are using more cement quantities, the high-strength concrete is also expensive. Naturally, because cement is expensive, the high-performance concrete, the high-strength concrete is becoming expensive. Even if you look at the IS code IS 456-2000, they have put a stipulation on the maximum cement quantity to be used in the concrete as 450 kgs per cubic meter. So there is a stipulation, that is a maximum limit, 450 kgs. You cannot cross 450 kgs to produce any concrete of whatever strength you want. Because this restriction is brought in, this higher cement content in the concrete can cause the shrinkage of the matrix, increase in the cost of the mix, and also a rapid loss of workability. So due to these reasons, the code has put a restriction on maximum cement content. Thus, friends, there is a need to develop high-strength concretes with limited cement content without sacrificing the workability when the concrete is in the green stage, and when it becomes hard, durability, and also keeping economy in mind. So to solve all these puzzles, high-performance concrete is the solution. Researchers have proposed high-performance concrete as a solution to all these puzzles. So as I promised you that I will tell you what are the different ingredients that are used in high-performance concrete. On the left side, you have the normal 4 ingredients: cement, sand, coarse aggregate, and water, which are used in the normal concrete. So in addition to these 4, we have other ingredients in high-performance concrete. Let us, on the right side, you will see the additional ingredients: fly ash, silica fume, the GGBS, that is the ground granulated blast furnace slag, RHA, this is the rice husk ash, metakaolin. All these are admixtures. All these are the admixtures. In addition to these admixtures, you have superplasticizers, viscosity modifying agents, processed aggregate, and also fibers of different types and materials. All these can be used to achieve the desired performance. So these are the various ingredients in high-performance concrete. What makes a concrete a high-performance concrete? The question, the strength or durability? Or both? My answer is both strength and durability will make the concrete as high-performance concrete. Can high-strength concrete also be a high-performance concrete? Not necessarily be, need not be. Because all high-strength concretes cannot be high-performance concretes also. Because, as I explained earlier, strength is not the only criteria with which we have to proceed. Performance is the criteria with which we have to proceed. So that is why all high-strength concretes need not be high-performance concrete. So all the factors to be considered in the design of the high-performance concrete I have just shown in this circular form. So if you see here, the structural considerations, the first thing is the structural considerations, which is very important. So why is this structure designed? What is the type of load the structure has to take? It's different from structure to structure. They differ from structure to structure. So structural considerations. Then if you come load considerations, what type of loads the structure is going to resist? Is it a static load, or it's a dynamic load, or it's a impact load, a blast load? What type of load it has to resist? Then what materials we have to use in the concrete? And what is the mixed design methodology we have to use? The mixed design methodology. Then what's the construction process? What type of construction consideration? And finally, environmental considerations. Environmental considerations. What type of environmental conditions the structure has to resist? Is it situated in a very highly rain pouring area? As we're placed in a very high coastal region? Or it has to resist the wave action, snow? All these things you have to consider, the environmental considerations. So all these factors are to be considered for high performance concrete. Then how to define the high performance concrete? We have to consider three influences while defining the high performance concrete. The influence of the structure, that is the support, including the support system, influence of the environment, influence of the loads. All these three factors we have to consider: the structure, the environment, and the loads. We have to consider in designing or in defining the high performance concrete. So there are several definitions I have seen on high performance concrete, but I have liked two definitions. One is given by Henry Russell and other by the American Concrete Institute. So let us see the two definitions given by these two institutions. As per Henry Russell, high performance concrete is a concrete made with appropriate materials, combined according to a selected mix design, properly mixed, transported, placed, consolidated, and cured so that the resulting concrete will give excellent performance in the structure in which it is placed, in the environment to which it is exposed, and with the loads to which it will be subjected to for its design life. So you can see the definition has taken care of all the three influences: the structural influences, the loading influences, and the environmental influences. So everything is taken care. This is one definition. And I also like the definition given by American Concrete Institute in the year 1998. As per ACI, the definition for HPC is the concrete meeting special combinations of performance and uniformity requirements that cannot always be achieved routinely using conventional constituents and normal mixing, placing, and curing practices. You cannot achieve, you just see this definition which says you can't achieve by routinely using the conventional constituents, that is the four conventional constituents: cement, water, coarse aggregate, and fine aggregate, and the normal mixing, placing, and curing practices. So you need something special to produce high performance concrete. So I promise you to tell what are the performance characteristics. When we are thinking of high performance concrete, what are the performance characteristics? I have listed several performance characteristics. So you can see high strength is one performance characteristic. High early strength. In some applications, we need very high early strength. Within 2 days or within 24 hours, you need a strength of 30 or 40 megapascals. High modulus of elasticity. High abrasion resistance. So if you are performing a runaway design, you need high abrasion resistance. Similarly, high durability and long life. For dams and water retaining structures, low permeability. For structures in aggressive environments, resistance to chemical attack. In frost areas, resistance to frost. Impact resistance. Volume stability. Ease of placement. Compaction without segregation. Inhibition of bacterial and mold growth. These are all the different performances, characteristics. So a concrete which you design may be for one or more combination of one of these performance characteristics. So you have to choose which performance characteristics you have to use in the design depending upon the purpose for which the structure is going to be used. Accordingly, you have to select the performance characteristics. So if you are designing a runway, you need high strength and also high abrasion resistance as performance characteristics. If you are designing a underground water structure, you need high early strength and low permeability. So like that, depending upon the purpose to which the structure is designed, you have to choose performance characteristics. So the different types of materials we use in high performance concrete and their primary contributions. So I just listed them out. You can have a quick look at them. Portland cement, the blended cement. In fact, blended cement is much better than the ordinary Portland cement. Blended cements contribute for durability and as well as high strength. For blending, we use many types of mineral admixtures like fly ash, slag, and silica fume. They all increase metakaolin, rhesus ash, calcine clay. These are all mineral admixtures. They improve the durability, reduce the permeability. Superplasticizers we use for getting the flowability and the workability. High range water reducers. As we know, if we want to achieve very high strength, we have to use very low water cement ratio. So to reduce the water cement ratio, we use what are called high strength water reducers. Then we have hydration control admixtures, retarders to control the setting, viscosity modifying agents to obtain the fluidity without segregation. As we know, segregation can damage the quality of the concrete. So we use VMA, the viscosity modifying agent. We have different types of fibers to improve the tensile strength of the concrete, where the concrete has to have a good tensile strength. Accelerators, if you want to have a quick setting. We have corrosion inhibitors. You know, if you are constructing a structure under benign conditions, corrosion is a great destructor. So to prevent the corrosion, we have corrosion inhibitors, shrinkage reducers, ASR inhibitors to reduce the alkali silica reactions, polymer and latex modifiers to obtain the durability, and the graded aggregates to improve the workability and reduce the paste demand. So from the different codal provisions, for the different types of properties of the high performance concrete, the criteria I have listed out here. If you say high strength is the property, then as per ASTM C39, it is 70 to 140 megapascals at 28 days to 91 days. High early compressive strength is 20 to 28 megapascals at 3 to 12 hours. You can see how early it is. Similarly, I have high early flexural strength, abrasion resistance, low permeability. As per chloride ion permeability test, it should be 500 to 2000 coulombs. So chloride ion penetration should be less than 0.07%. So high resistivity, low absorption, for all this I have prescribed for the codal limits. I have just listed the codal limits. You can just go through them. Sulfate attack, the modulus of velocity, high modulus of velocity more than 40 gigapascals. So that is high resistant to freezing and thawing. So the different types of freezing and thawing cycles. All this I have listed. Please have a look at these properties. So when you come to concrete mixes, we have the nominal mix and we have a design mix. In case of a normal concrete, we cannot have, we may go with a nominal mix, but for high performance concrete, you don't have any other method other than design mix. You have to use the design mix. So in the nominal mix, you have fixed proportions, normal conditions, no account of material characteristics and no control. Whereas in the design mix, the proportions are designed and the specified properties are satisfied. And we have a good control on fresh and hardened states. That is why in case of high performance concrete, we have to always go for a design mix. So if you look at the mix design for any concrete, we have to have a right combination of the cement, the aggregates, both coarse aggregate and the fine aggregates, the water, and the different admixtures. So the mix design is an art. I always say, like you make a biryani, you cook a biryani, it's an art. So the proper combination of the masalas, the rice, the chicken or the mutton, and the gravy, the ingredients, proper combination and the quantities have to be put in to make the biryani, to cook the biryani tastefully. Same way, you have to cook the high performance concrete mix design. What are the aims of the mix design? We have to comply with strength, the workability. The concrete should be workable, durable, and economical. So all these factors you have to keep in mind while doing the mix design. You all know workability is very important to put the concrete in place. So in the green state, the stability, the mobility, and the placeability are very important. The cohesiveness of the concrete, the high performance concrete, compactability, how easily we can compact, and the finishability. These are very important to get a good finish. And if you look at the strength aspects, you know, the strength is inversely proportional to water cement ratio. So it is always better to use very low water cement ratio to get good performance, high strength. And if you look up the types of cements, the fineness of the cement, the chemical composition of the cement, these are very important. What type of cement you have to choose for high performance concrete, and how much curing time is required and what temperature we need to maintain during the curing temperature. These all affect the strength of the concrete. And as majority of the strength is contributed by the aggregates, their characteristics like size, shape, strength, and grading, all these will influence the strength of the concrete. So all these factors you have to consider while designing the mix for the concrete. Now, if you look at the durability, which is very important, durability, that is the ability to endure weathering action. To achieve this, we have to minimize the cement content so that we maintain the required alkalinity to provide passive environment against corrosion of the steel. If your concrete is more acidic, the reinforcement steel that is inside the concrete has got more chance to get corroded. So it is always better to see that sufficient alkalinity is there in the concrete to have a passive environment against the environmental conditions to protect the steel from the corrosion. So you have to place a limit on the maximum water cement ratio, because if you go on increase the water cement ratio, the permeability of the cement paste increases. If the permeability increases, there is more chance, there is more likelihood for the environmental conditions, environmental things to penetrate into the concrete easily and attack the concrete and the reinforcement steel. So we have to have a high on maximum water cement ratio. How the reduction in useful life of the structure can be controlled and achieve that the structure performs for its design life period. This is all the durability aspects which you need to consider. So all cement, aggregates, water and admixtures, these are all important in the design of concrete, and I'll just go through this very quickly because the principal constants of the cement, you know, tricalcium silicate, tricalcium aluminate, dicalcium silicate and tetracalcium aluminoferrite. All these are the principal constants of the cements, and nowadays we have different grades of cement, 33 grade, 43 grade, 53 grade. So what type of grade of cement we have to use? So is a higher grade of cement more beneficial? Because what is high grade cement? If you take a 53 grade cement, it has got more fineness and more C3S content. This is achieved with rapid cooling of the clinker in the cement manufacturing state. So if you choose a high grade cement, we get high early strength, but you have to focus on how to reduce the cement content using a high grade cement. That is a mixed design. In the mixed design, you have to see that you can reduce the cement content by using the high grade cement to achieve economy. But high grade cements have got their own demerits because it may deteriorate the structure rapidly. We have problems with shrinkage because it causes greater heat of hydration and cracking as it's very fine cement, and that's why the structure becomes less durable. So all these disadvantages are there. So you have to properly decide which grade of concrete, which grade of cement you have to use, depending upon the type of purpose to which you are designing the structure. If you are designing a structure for underwater, say you need high early strength, then you have to go for a high grade cement. Aggregates, you know, these are cheap fillers. They provide the strength to the concrete. They reduce the volume changes and they provide the abrasion resistance. They occupy about 80 to 85% of the concrete volume. And the size of the aggregate shall be smaller than the size. And if the smaller the size of the aggregate, larger is the surface area. So this increases the cement content and reduces the workability. So that is why it is better to use a proper sized aggregate. And this is all, you know, the shape of the aggregate, how it affects the workability, the rounded aggregates, angular aggregates. So, you know, angular aggregates are having more bond and give more strength, but they are less workable. Because they are less workable, we need more cement. So the question to the mixed designer is economy versus durability. So what he should focus? He should focus on economy or he should focus on durability. So a proper combination of these two, the economy and durability, has to be achieved in designing the high performance concrete. So this is all, you know, the grading of the aggregate, how it affects the density and all. I'm not just going in detail because of the lack of time. And you know about water also. Water is needed for two purposes in the concrete. For chemical reaction with the cement in hydration process, that is the primary need of the water. And the secondary need of the water is workability. So, you know, only 1/3 of the water is needed for chemical reaction. It's very important. Please, you always think that more water is needed, but no, we need only 1/3 of the water for chemical reaction. For the rest of the water we add is only for workability. So more water results in porosity, and the proper judicious water cement ratio is to be chosen, because if you use more water, It's good for plastic shrinkage, but it is bad for permeability, strength, and durability. So a proper choice is to be made. And generally the thumb rule is the water must be potable, that is, it must be drinkable, and it should be clean and should not have any pronounced taste. It should be free from excess salts, oils, acids, alkalis, and organic materials. So various limits of water as per the codal conditions I have just limited out there. You can just see the list. And we use admixtures in high performance concrete. The chemical admixtures were used to act as retarders to reduce the setting times, or means to increase the setting times, accelerators to reduce the setting times, water reducing agents, air entraining agents, all chemical admixtures we use in high performance concrete depending upon the purpose for which it is used. In case of mineral admixtures, we use fly ash, silica fumes, slags, ricer's cash, and all these things are used. You know, fly ash is a byproduct of thermal power stations. I think I'll all skip this because of the lack of time. Fly ash, we have class C fly ash and class F fly ash, and the requirements of the different fly ash and the benefits of the using fly ash. Fly ash contributes to durability. Similarly, silica fume is a byproduct in the manufacture of silicon and ferrosilicon alloy industries. Is a product that comes from quartz. Silica fume comes from the quartz. It has got a very huge surface area. So it's a wonderful mineral admixture, silica fume. So I'm just skipping all these because of lack of time. So it's a specific gravity of around 2.2, and you can see the fineness is 20,000 cubic meter square per kg. It's a very high surface area if you test the silica fume by Blaine's operators. So silica fume acts in different ways in concrete and improves the durability. So I'm not just giving these. So properties of the fresh concrete, if you see, ease of placement, resistance to segregation. This is very important. Segregation we should always avoid. And the concrete should be in a homogeneous mass. And it should be consistent and have a good flowability. So as high performance concrete consists of several ingredients, and also we'll be using a very low water cement ratio. Thorough mixing of ingredients of concrete and proper sequence of feeding is very important, and it shall be ensured, but that the mixer shall not be loaded more than 50% of its full capacity. And we may also lead a longer mixing time in case of a high performance concrete. So the important properties of the hardened concrete, if we come, the strength and durability, different types of strengths. We have compressive strength, tensile strength, and flexural strength. In normal concrete, we'll be focusing more on compressive strength, but in case of high performance concrete, we have to consider compressive strength, tensile strength, flexural strength, and as well as modulus of elasticity also. So the durability aspects also we have to focus in high performance concrete. Alkali silica reaction to be avoided. Maintain a good abrasion resistance. Good resistance to freezing and thawing. To reduce the open pores so that there is no growth of bacteria. To achieve all this, we have to have a dense structure, low permeability, and a discontinuous capillary pore system. A discontinuous capillary pore system. So there should not be a continuous capillarity. This gives high durability to high performance concrete. So the choice of mixed proportion depends upon the grade of concrete which you are designing. Are you designing an M60 concrete or M100 concrete? The type of cement you are using, the size and shape of the aggregate, the grading of the aggregate, water cement ratio, the workability, durability, and the quality control issues. All this, they play an important role in mixed proportioning. For the normal concrete, you have got different mixed design procedures are available today. We have IS code method or ACI method or many other methods available, but for high performance concrete, we don't have any standard mix design method. The basic mix design procedure followed for high performance concrete is by trial and adjustment. So conduct several trials and go on adjust your mix proportions. Absolute volume method is generally used for mix design of the high performance concrete. And in 2008, we proposed Vaishali's method, a doctoral research at JNT University, Hyderabad, we have undertaken. And this method is somewhat more rational, as in this method, a relationship between the water cement ratio, the water binder ratio, and the various strengths of the concrete, the compressive strength, the tensile strength, and flexural strengths have been proposed. So as per this relation, you can choose the water binder ratio required to achieve the required compressive strength, or required tensile strength, or required flexural strength. And also, charts have been provided in Vaishali's method of mix design, which uniquely combine both strength and durability aspects. For the durability aspects, the charts have proposed resistance to various acid attacks like H2SO4, the sulfuric acid, the chloride HCl, and also magnesium sulfate. So in addition to this acid attack, the charts also have combined what is called as chloride ion permeability as a measure for permeability. So what is the desired level of permeability you want? What is the desired level of strength you want? Accordingly, mix design based on charts has been provided in Vaishali's method using relations between water binder ratio and the different types of strengths. So whatever method you are using for mix design, you have to remember that for given water cement ratio, use of large size of aggregate results in less cement. Round shaped aggregates, they give less cement. And for more workability, use higher water cement ratio, or for constant water cement ratio, use super plasticizers and drop the aggregate cement ratio. So, 1 gram of cement requires about 0.253 grams of water. This is very useful thumb rule. And 7-day strength is about 2/3 of the normal 28-day strength. So if the temperature in the environment is more than 38 degrees centigrade, prefer night concreting. Adopt always wave batching, don't go for volume batching. And skilled person should be used in the mix designing and mixing. And you can ensure the cohesiveness of the concrete with the ball test and control the water content. As you know, water is dangerous for the concrete. And the proposed sand contents, the different grades, IS 600, IS 300, IS 150 microns. So 30 to 35%, 15 to 20% of 300, and 3 to 5% of IS 150C. So with our experience, we have given here some typical high performance concrete mixtures which you can use for different purposes. So how can we extend the service life and decrease the maintenance of concrete structures? How can we extend the service life and decrease maintenance of the concrete structures? The answer is use of high performance concrete. This is the answer. So now I'll go to the second part of the presentation, where we'll be using artificial neural networks for modeling the concrete. I'll present the brief principle of artificial neural networks, and interested researchers can pick up from that and also can contact me for softwares available. Also, I can provide the young researchers with the platforms. Even a MATLAB also, today we have the platform to design in artificial neural networks. So first of all, let us try to understand the concept of the artificial neural network. If you look at our brain, human brain, the human brain consists of biological neurons. The human brain consists of biological neuron. So this is a typical biological neuron. This is a typical biological neuron. So a biological neuron has got three important components. One is the nucleus or the cell body of the neuron. The nucleus or the cell body of the neuron. So that is the life. This is the life. The dendrites, all these projections are called dendrites. Okay, these are all the dendrites. So these dendrites, they collect the information from other biological neurons. They collect the information from other neurons. And the third important component is the axon. This is the axon. This axon delivers the signal to other biological neurons. So please understand this concept. The biological neuron has got three important concepts. One is the cell body, the dendrites which collect the information from the other neurons. So these are called the input. Dendrites are the input, and the axon delivers the signal to other neurons, so it is output. The axon is the output. So the artificial neuron, an artificial neuron is promulgated as a simple mathematical model of this biological neuron. This is biological neuron. So here I am showing you the artificial neuron. This is artificial neuron. So this is the cell body. Okay, this is the cell body where the processing takes place. This is the cell body. Here we are going to give inputs. X1, X2, X3 are the inputs. Okay, these are the inputs. So these are performing the job of dendrites. These are performing the job of dendrites. And each input is multiplied with certain weightage. Each input is multiplied with certain weightage. So the weightages are W1, W2, and W3. So we get the synaptic strength is the weighted sum, that is W1 X1 plus W2 X2 plus W3 X3. So if this weighted sum exceeds certain threshold, then we get the output. We get the output. So this is axon. The output is performing the axon. So there are different types of output functions to deliver the outputs that we use in the neurons. So here I am using a simple output function 1 by 1 plus e to the power of minus x. So you can use different types of output functions. In the literature you have different types of output functions. So there are different types of neural architectures. But the most popularly used neural architecture is a feed-forward neural architecture. So a feed-forward neural architecture will consist of an input layer. This is the input layer from where we give inputs. There is an output layer. So this is the output layer. And there will be hidden layers between input layer and the output layer. There are hidden layers. So these are all called input neurons. These are neurons in the hidden layer. And these are the neurons in the output layer. The neurons in each layer are connected to all other neurons in the subsequent layer. They are connected to all other neurons in the subsequent layer. Okay, this is called a simple feed-forward neural architecture. So what we do in artificial neural network training is first we take a selected input vector and a correspondingly the output vector. Okay, the selected input vector for which we know the output vector. So we give inputs at the input neurons and we assume the weights. We assumed the weight matrix as the random matrix. Initially, we don't know the weights. So we assume the weights as the random weights. And now we give the inputs. The inputs get multiplied with the weights and output is delivered to the next layer. From this again, this output is multiplied by weights and again output is delivered to the next layer. From there we get what is called as output layer. The output layer generates the output. So this output layer, whatever signal, output signal is giving, we will compare with known outputs. Initially, we compare with the known outputs. So we'll observe what is the difference between the known desired output and the output delivered by the network, neural network. That difference we call as error. That difference we call as the error. So what is the output given by the network and what is the actual output? We'll compare these two. So the difference between the actual output and the output delivered by the neural network, we call it as a error. And this error is again back propagated from output layer to the hidden layers and hidden layers to input layer. In this process, the weights get modified by a proper back propagation algorithm. Back propagation algorithm. The back propagation algorithm is an error minimizing algorithm. It is an error minimizing algorithm. So in which we use the least square method of error minimization. The least square method of error minimization. It's all mathematics you don't need also. But just I'm giving you the fundamentals. So it uses the error minimization algorithm. So again, we come back to the input layer. Again, the modified input is again submitted in the forward direction, the second cycle. Again, we get certain output. Again, we get certain error. Again, this error is back propagated. The modified input is again submitted in the forward direction. So like this, the process of training takes place into number of cycles. The training cycles go on and go on and go on. And in each training cycles, if your network is converging, your weights are getting updated. Your weights are all, the connection weights are all getting updated. And at one stage, the weights get updated to such a level that the output predicted by the network is exactly equal to the actual output or within the permissible limits of the error. We measure the error and with the training cycles improve, the RMS error goes on decreases. And at one level, we can say that the network has got trained if the RMS error is less than 1% or 0.5% at whatever the desired level of accuracy you want. So this type of neural architecture is very important in the mixed design of high performance concrete because high performance concrete it contains different types of admixtures in addition to the normal ingredients. So if you want to measure the strength or the durability aspects of the concrete, you have to actually cast the concrete in the experimental procedure, do the testing, wait for 28 days, then only you will know. So this makes the process very delayed and expensive. So if you derive an ANN model, if you derive an ANN model which mimics the human expertise with its past experience, the model will be able to predict the strength and durability aspects even before casting the concrete in the experiment, in the laboratory. So you save time, you save money, you save the material. So by seeing the predictions of the neural network, you can modify your mixed design so that the desired levels of the strengths and durabilities are achieved. Once you satisfy with the mixed proportioning using your artificial neural network predictions, you can now actually cast you may do the trial. So what is happening? The trials are reducing considerably. With the help of ANN, you are able to reduce the mixed design trials that are required to design the high performance node. This is a simple flow chart which shows the training process. The input is given first at the input layer, then it goes to hidden layers, hidden layer 1, so it receives the weights. Then the further output goes to layer 2, again it receives the weights. It gives the output y, the prediction. Okay, it is compared with the true value of y, the output. So if the error is there, then it will be back propagated to the optimizer through error minimizing optimizer. So weights get modified, and again the process of input continues till we get the loss function. The error, RMS error, is very, very less. So let us now briefly discuss about what are the various processes that are involved in developing this feed-forward neural network architecture. So first of all, you have to decide what are the network parameters, such as the number and size of the different layers of the network, what nodal function you have to use. Then you have to select the parameters for the information flow within the network, that is the input and output pattern, and what normalizing factors you have to use. What is normal? Oh, please hold on. I'll plug in my battery. Yeah, sorry for the interruption. So selection of the learning rule, which learning algorithm you want to use, backpropagation method, or what type of learning rules, that also you have to select. Then you have to initialize the network parameters, that is the weights. These things you have to choose. Then there's a typical backpropagation algorithm. I just don't want to go into this mathematics of this because it is sufficient. You understand that backpropagation algorithm is used. So in this particular work, we have used genetic algorithms to combine with the backpropagation algorithm to improve the speed of the network and also to reduce the number of cycles of training that are required. Genetic algorithms are the mimic of the principle of natural genetics and the selection to construct a good search and optimization. These are very good in taking larger and potentially huge search spaces, genetic algorithms, like if you are training a huge data. And the striking difference between
also all the remaining who want to success in their streams, and the third year and second year students, I tell you just get a clear picture.
Optimization method. So this is the, somebody please switch off your microphone. Somebody is disturbing me.
Within this year, many improvements took place in college and also in department. Many trainings are being given to the students and also many opportunities.
Somebody please switch off your microphone. You are talking, it's disturbing me. So this is the simple flow chart of genetic algorithms. I'm just going fast because of the lack of time. So initialize the population is the initial population. Then we use what is called as a fitness function to calculate the fitness calculation. The principle here is the fittest of the genes will survive. The fittest will survive. So depending upon the fitness calculation, we see whether we go to the output function or otherwise we again go back to selection. The basic principle will be the crossover and mutation. So just any standard textbook on genetic algorithms will give you the details of this because lack of time. I am not able to deliver this. So this is the test program we have used. We have used cement, metakaolin, and silica fume and fly ash. The basic materials, metakaolin, silica fume, and fly ash are the mineral admixtures. And we have also used the super plasticizer for reducing the water cement ratio. So these are the various properties of the materials. I'll just quickly go through. These are the parameters, different parameters we have considered for the experimentation to derive the training examples for the network. These are the various, so the water cement ratios we have used from 0.3 to 0.5. We used the 3 aggregate binder ratios, 2, 2.5, and 3. We have used a fixed superplasticizer dosage, and we have used the replacements of cement with admixture 10%, 20%, and 30%. We have used the workability properties as per IS 1199, the mechanical properties as compressive strength, physical tensile strength, and flexural strength. The permeability properties as chloride ion permeability test. And these are the variation of the experimental results, the compressive strength versus water cement ratio curves, compressive strength versus water cement ratio. Then we have the various tensile strength and water ratio curves. Huge data is generated in the experimental method, and these curves have been used. These are the flexural strength and water cement ratio. This permeability versus water cement ratio. These are all self-evident. That's why I'm not explaining these things. These are self-evident. So all this huge data has been used to derive. This has been used to derive the water binder ratio relationship with strength properties and the durability properties. Chloride ion permeability has been measured with a chloride ion permeability apparatus as per ASTM-C 1202. So the GA-based artificial neural network model, we were prepared for workability, strength, and durability. So for predicting the workability, for predicting the strength, that is compressive strength, tensile strength, and flexural strength. And for the durability, for predicting the resistance to acid attack and as well as the permeability. So permeability, we have taken chloride ion permeability. So with all this experimental data, we have trained the genetic algorithm based neural network model. We have trained the network model. So these are the various stages that are involved in training the neural network model. The first step is generation of exemplar patterns. That is examples, training examples needed. This we have done by conducting experimentation in the laboratory, by casting different types of specimens and testing. So we got the example patterns from experimentation. Network type selection, we have used a feed-forward neural network architecture. The input and output, depending upon input, are all our water cement ratio, percentage replacement, then all these are the inputs. The outputs are workability, the strength, and the durability are the outputs. So we did a trial to arrive at the suitable network configuration. Then we proceeded to train the network using GA modified with the backpropagation algorithm. Once you do the training of the network, then you have to validate the resulting network. What is validation? It is different from training. Say, for example, you have 2000 training examples with you. 2000 examples with you, experimental data, 2000 examples are there. So for which you know both input as well as the output. In 2000, say for example, 1800 patterns you use for training. 1800 examples you use for training. 200 examples you hide, you don't give it to the network. So once you use 1800 training examples and train the network, once you are satisfied that the network is trained, then you go for validation. Validation is the process in which we will be presenting a new example to the network, which was not given to it earlier in the training. So see what the results the network is predicting for the new examples. So even for that, if the network is predicting closely with your experimental result, then you can say that network is validated. So the training and validation are very important aspects of the network. So the input and output parameters, water binder ratio, aggregate binder ratio, the type of mineral admixture, whether it's a fly ash or whether it's a metakaline or silica fume, their percentage replacement. So all this becomes the input vector. I have given the input vector here. The output vector is compressive strength, tensile strength, the flexural strength, and Young's modulus also included in the output vector. So this is a strength model. This is the strength model. So similarly, we have derived for durability model also. So if we use what are called as scaling factors to improve the training, the scaling factors will reduce your input and output into the binary form. So you have to choose proper scaling factors. So this table explains how to choose the scaling factors. So here we have tried different types of configurations. This is a 4 input and 4 output is constant. The hidden layer neurons we have tried with 20, 22, then 23 and 24. So all these configurations we have tried, and we found that 4-24-4 feed forward network architecture. So 4 input, 4 output, and 24 hidden layer neurons is found to be very good for the purpose which we have chosen. So this particular network 4-24-4 network is trained with different training in number of training cycles, 100 to 2000 cycles, and we can see the RMS error is reducing gradually. So RMS error is reducing gradually. So after 2000 cycles, the RMS error is 0.001%, very, very less, 0.001. So it is 0.1%. So the RMS error after 2000 cycle is very, very less. So we, at this stage, we think that the network training is completed. So here I am showing you how the network is formed, the comparison between the actual value and the value predicted by the network for different strengths, compressive strength. So you can see the network has predicted very closely to the actual values. So the training process is very good. Similarly, you see validation. After the training is completed, you have to validate the network. So present the network with examples which are not in the training set. So even for new examples, you can see the network has predicted the values of the compressive strength, tensile strength, and flexural strength closely with the actual data. So now you can say that the network has validated. In the same way, we have trained another model to predict the permeability, the chloride ion permeability. So there also we have tried different types of models. So 4-24-1 is best suited. So this is the model which we have trained for permeability prediction. 4 input neurons, 1 output neuron, that is permeability. And then these are 24 hidden layer neurons. So this model has performed well. And you can see the training process and the validation. So from this, we can conclude that artificial neural networks combined with genetic algorithms can give a wonderful solution to predict the mixed design parameters for high performance concrete. So the theme of today's presentation, just to review back, so modeling the high performance concrete with a hybrid neural network, because hybrid means here genetic algorithm plus back propagation is called a hybrid neural network. So we understood what is the necessity of the high performance concrete and how it is different from ordinary concrete, and how to achieve high performance concrete, and what are the challenges in the mixed design of high performance concrete. And we understood how artificial neural networks can come in and help us in designing the mixes for high performance concrete. We understood the concept of the biological neuron, the principle of the artificial neuron. We understood what is a feed forward neural network architecture. We also understood the backpropagation algorithm principle of error reduction, and we understood what are the various stages in the development of the ANN model, how to train this, how to validate this. So this is the sole theme of my today's presentation. Thank you very much for your patient listening, and I'll be glad to answer if there are any queries. Thank you very much.
Sir, thank you so much for your valuable and productive presentation, sir.
Thank you.
And I also wish that participants have utilized this session in a very well-mannered way. Sir, we would like to have more 10 minutes from your side for the
Yeah.
questionnaire session.
Sure, no problem.
I'll be putting my first question from Nagaraju, sir. What is the major difference between HPC and HSC?
Yeah. High strength concrete is a concrete which possesses a compressive strength of more than 50 megapascals. So here the focus is again only on the compressive strength. The focus here is again only on the compressive strength, high compressive strength concrete. Whereas high performance concrete is designed to perform the given performance characteristics. Strength may not be the performance, or compressive strength may not be the performance characteristic. Say, for example, I told you, if you are constructing a underwater structure, so there high early strength is required. A quick curing, quick setting is required. It is not the compressive strength, high compressive strength. We want high early strength. Similarly, if you are designing a airport runway, there the abrasion resistance is important, not your compressive strength. So depending upon the structure, what is the purpose for which it is designed, the structure, so the performance characteristics will vary. So a concrete which satisfies the performance characteristics required for that structure is a high performance concrete. Whereas a concrete which gives only strength, high strength,
Sir, your voice is not audible, sir. Hello?
yeah, yes, please.
Is my voice audible to you, sir?
Yeah, very much audible.
Okay, sir. Thank you for your answer, sir. And we have a few more questions. And the second
Yeah.
question is from Mr. Varaprasad.
Yeah.
How much percentage of data is required for validation out of total data available?
So generally we use 10 to 15% of the data for validation purposes. We use about 80 to 85% data for training the neural network, and about 10 to 15% of the data we use for validation purposes. But it is not only the volume which is important. We also have to keep the patterns, different patterns also in mind while choosing the validation data. So that is very important. Volume is one criteria, and the type of patterns, different patterns also you have to keep in mind choosing the validation data. You have to validate the network in such a way that all patterns it is able to predict. So that's why you have to test in all the patterns. So you hide all the pattern data. That is what is very important.
Thank you, sir.
Yeah.
The other question is, what is the amount of data required for ANN model development with sufficient reliability?
It's a very good question actually. It's a statistical model. So whatever statistics you use in optimization principles, so the same type of optimization we use in neural network modeling. So whatever principles of statistics we adopt in optimizer, the same principles are valid even for neural network optimization. Depending upon the type of the network you are proposing, the data sets you have to decide. So generally 100 to 150 data sets will be very good for a concrete problem. I hope Paraprasad, I have clarified your doubt.
Thank you, sir. And one more question from Srinivasulu.
Yeah.
Generally, where do we use high performance concrete?
Mr. Srinivasulu, we have to use high performance concrete everywhere. I would say we have to forget about our normal concretes, which are strength-based designs. We have to use the high performance concrete in every application. So depending upon the type of application, you have to design your concrete. That is as simple as that. So if you want a D vitamin, you have to stand in sun. If you want B vitamin, you have to take that food which gives you the B vitamin, or you have to take supplement. So what you want, you have to accordingly act. So if you want the structure to design to resist the environmental attacks in a coastal area, accordingly the performance criteria is permeability. So like that, you have to choose the performance criteria and design your concrete. Please don't get confused that high performance concrete is a concrete which has got 60 megapascal strength or 100 megapascal strength. High performance concrete is a concrete which satisfies the performance criteria required for that structure. So that way I would say every application you should use high performance concrete. We should slowly shift towards high performance concrete.
Thank you, sir. And we have one last question from Muhammad Rafiq.
Yeah.
For HPC, whether industrial waste like gypsum, red mud, copper slag, etc., can be used as a fine aggregate.
Yeah, it's a very good research topic. What you have proposed, Mr. Rafi, is a very good topic. Phosphogypsum is one material which is available in huge quantities in fertilizer industries as a waste product. But the issue is it possesses certain radioactivity. The phosphogypsum possesses certain radioactivity. So it emits radioactive rays. So you have to be very careful with the limits of the radioactivity for the human exposure. So it's a good area. Phosphogypsum can be used as a replacement to the natural sand. We have done some trials with using phosphogypsum as a partial replacement to cement. Not in high performance concrete, but we have tried in self-compacting concrete and we have got good results also. So definitely, Mr. Rafi, you can try with that, and can only thing you have to keep in mind is its radioactive properties. See that the radioactive properties are within the limits that easily can be absorbed by a human being. That's what you have to keep in mind.
Thank you so much, sir, for clearing all the queries from the participants.
Yeah.
And now I would like to thank you for your time and for this excellent presentation, sir.
Thank you.
And we also look forward for you with more presentations like this. And now I'm handing over this session to my HOD, sir, for the vote of thanks.
Okay.
Sir, good afternoon, sir. Sir, thanks for your enlightening the session, sir. The topic is very useful. And thanks for the wonderful session, sir. Today's session was very informative and knowledgeable session, sir. We look forward for more sessions with you, sir. I'm privileged to say vote of thanks for first day of an FDP. I feel privileged on this occasion to deliver my vote of thanks for the first day of FDP on emerging trends in civil engineering. Firstly, I would like to convey our sincere thanks to today's resource person, Dr. H. Sudarshan Rao Garu. And I would like to convey my personal thanks to Correspondent Madam, V.K. Padmavatama Garu, Managing Director, Gajra Ramnath Reddy Garu, Director Madam, V.K. Srivani Garu, and Principal, Patel Bhaskar sir, for the motivating and supporting and encouragement. I would like to a heartfelt thanks to my fellow faculty members who've been supporting me in all tasks for organizing this FDP. Last but not the least, I thank all the participants throughout the country and across the globe for the time of patience in making the first day of FDP a grand success. We wish you your presence for tomorrow's session. Now we are closing the session, sir, on the count of 5. 5, 4, 3, 2, 1. Thank you, sir.
Yeah, Ritish, are you there?